Welcome to Algebra 2, Unit 7, Section 2, Polynomial Synthetic Division. After this lesson, you should be able to divide polynomials by using synthetic division and evaluate polynomials using remainder theorem. Okay, so synthetic division is nothing more than a shortcut method to divide a polynomial by a linear binomial using only coefficients. The rules are you have to have the polynomial written in standard form. You also have to put a 0 in for any missing terms. And the divisor must be in the form of x plus a value a, in this case, or x minus a. So here we'll go through some examples as to where and when you can use synthetic division. So in this first one, all you have to do is you look right here, and this is x plus 3, that's acceptable. So you can use both of these. You can always use long division. The second one, we do not have a binomial, so you can only use long division. This third one, you can use both long and synthetic division. All right, so let's go through the steps of this process. All right, so the first thing you're going to do is set the divisor equal to 0 and then solve. All right, so this is the divisor right here. So we're going to say x plus 3 equals 0. So subtract 3 from each side, I end up with x is equal to negative 3. The next time I'm going to put this polynomial in standard form. So the standard form is negative x cubed plus 2x squared plus 0x minus 3. Okay? So this is the part we were talking about. We don't have any x's, so we're going to put this in here. And now what we do is we take this 0 and we put it right here. Okay, so the 0 goes right here. And then we write out all these coefficients. Negative 1, 2, 0, negative 3. Okay, so the first thing we do is we bring this down. So this is negative 1. Then you're going to multiply negative 3. So we're going to multiply this value here times this, and you put your answer up here. So in this case, negative 3 times negative 1 is positive 3. Now we just add down the column. 2 plus 3 is 5. Negative 3 times 5 is negative 15. Add down the column. 0 plus negative 15 is negative 15. Now we multiply again. Negative 3 times negative 15 is positive 45. Negative 3 plus 45 is 42. Positive 42. This is your remainder. If it's anything other than 0, this is the remainder. So now we put this in this form. Negative x squared plus 5x minus 15 plus 42 over x plus 3, right? Our divisor, right? So that's the process. It's not that bad once you practice it. Okay? So if you remember, there's a little bit different levels of work with this. So let's do a long division versus a synthetic and see how it goes. Okay, so we're going to write x plus 2 here divided into 2x cubed minus 3x squared plus 4x plus 5. So x goes into 2x cubed, 2x squared times. So now we multiply and change the sign. 2x squared times x becomes 2x cubed, but we change the sign to negative. 2x squared times positive 2 is 4x squared. Change the sign to negative 4x squared. Okay, remember we have to do that every time. Add down your columns. 2x cubed plus negative 2x cubed is 0, so that's gone. This is negative 7x squared. Bring down 4x. Now, x goes into negative 7x squared, negative 7x times. So now we multiply. Negative 7x times x is negative 7x squared. Change your sign, plus 7x squared. Negative 7x times 2 is negative 14x. Change the sign to plus 14x. Add down. I end up with 18x plus 5. So now we're going to multiply. This goes in plus 18 times, right? So this is negative 18x. 18 times 2 is 36. Change the sign to negative 36. Add down, and we end up with negative 31. So our final answer is 2x squared minus 7x plus 18 minus 31 over x plus 2. And there's your answer. Now, synthetic division, we should end up with the same exact answer. But we're going to end up with is the 0, what turns this into 0 here, x plus 2, is negative 2, right? Now we write our coefficients down. 2, negative 3, 4, and then 5. So this 2 comes all the way down. Negative 2 times 2, negative 4. This becomes negative 7. Negative 2 times negative 7 is positive 14. Add that together, that's 18. Negative 2 times 18 is negative 36. Add it together, I end up with negative 31. So our final answer is 2x squared minus 7x plus 18 minus 31 over x plus 2. And we should have identical answers, and we do. Okay, those two are identical. Alright, so that's when we can do synthetic division. Let's try a couple more. So the 0 on this problem is -3. So I've got 6, -5, -6. 6 comes down. -3 times 6, -18. So this is -23. -3 times -23 is +69. So this would be -63. So our final answer should be 6x minus 5. Oh, excuse me, not minus 5. What am I looking at? 6x minus 23 minus 63 over x plus 3. Okay, this problem here, right? 4, 3, we're missing x squared, so we're going to have to fill in here. X minus 3, the 0 is 3, so we're going to have 3. And we've got 1 minus 2. We're missing an x squared, so it's plus 0x squared, 3, and then 1. Right? So 1 comes down. Now we multiply. 3 times 1, 3. -2 plus 3 is 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. 3 and 9 is 12. 3 times 12 is 36. And 1 and 36 is 37. So our final answer, x cubed plus x squared plus 3x plus 12 plus 37 over x minus 3. Okay, so we have a polynomial here now, and they ask questions such as, is x minus 2 a factor? So the easiest way to decide this is to do polynomial division. Now my guess would be quite possibly because the last number is -20. But we can't automatically assume that it is. So we put our 0 in here, 2, and we've got 1, 6, 1, -24, -20. So 1 comes down, 2 times 1 is 2, 6 and 2 is 8, 2 times 8 is 16, 1 and 16 is 17, 2 times 17 is 34, -24 plus 34 is 10, 2 times 10 is +20, and this is 0. When we have 0, there's no remainder. So this is a factor. X minus 2 is a factor. Let's try this one. 5. And again, it's 1, 6, 1, -24, -20. 5 times 1 is 5. The 6 and 5 is 11. 5 times 11, 55. And 1 is 56. 5 times 56 is 280. So 280 and negative 24. And I'm a little slow in the head this morning, so I'm going to do a little. So it's 256. And 5 times 256 is 1280 minus 20, and that is 1260. So x minus 5 is not a factor. Okay, let's continue on here. Okay, if a polynomial p of x is divided by x minus r, the remainder is a constant p of r. And so the dividend p of x equals the quotient q of x times the divisor x minus r plus the remainder. Okay, so polynomial remainder theorem basically says if I divide a polynomial by x minus r, the remainder is going to be a number, right? And then divided by whatever we're dividing by. So we plug in this value r into a polynomial, and will tell us what the remainders would be. So basically all we're going to do is we're going to do p of 2 here. Okay, so that would be 2 times 2 cubed plus 5 times 2 squared minus 2 plus 7. I just plug this in. So this is equal to 2 times 8 plus 5 times 4 minus 2 plus 7. So I've got 16 plus 20 minus 2 plus 7. So p of 2, 16 plus 20 is 36, minus 2 is 34, plus 7 is 41. So if I were to divide by x minus 2, I would have a remainder of 41. Okay, that's all that this is saying. So over here we have x equals 3. So we would solve, we're going to plug into for p of 3. So this is 3 cubed minus 4 times 3 plus 5 times 3 plus 1. Well, 3 cubed is 27. Oh, 3 squared here. 3 cubed is 27. Minus 4 times, so 3 squared is 9, 4 times 3 is 36, plus 15 plus 1. Well, 27 minus 36 is negative 9. Negative 9 plus 15 is positive 6. 6 plus 1 is 7. So p of 3 is 7. So if we divided this by x minus 3, we would have a remainder of 7. That's all that this is saying. Okay, so let's take a look at this here. All right, so we're going to divide by 2. Right? When it's plus, okay, then you would change the sign into negative, and we'll go over that for the next problem. So p of 2 is equal to 2 to the 4th plus 7 times 2 cubed plus 5 times 2 squared minus 4 times 2 plus 15. So 2 to the 4th is 2 times 2 is 4 times 2 is 8 times 2 is 16. 2 cubed is 8, so 7 times 8, that's 56. 2 squared is 4, 5 times 4 is 20, 4 times 2 is 8, and then plus 15. So we've got 16 plus 56, that's equal to 72, plus 20 is 92, minus 8 is 84, plus 15 is 99. Now we could take a look at this and say, okay, is that actually what it would be? Well, we could plug this into synthetic division and see what we get. So let's do that really quick, just to prove our point. So this is 2, and we're going 4, 3, 2, 1, 0 here with this. So we'll put our, so here's 1, and then 7, 5, negative 4, and then 15. And let's see what we get. One comes down, 2 times 1 is 2, 7 and 2 is 9, 2 times 9 is 18, 5 and 18 is 23. 2 times 23 is 46. 46 and negative 4 plus 46 is 42. 2 times 42 is 84. And we add that down, we get 99. And you will see here, we got the same values. So that's what remainder theorem helps us do. Okay, this problem here is p of x is equal to x to the 4th plus 3x cubed minus 3x squared minus 6x plus 8 for x plus 4. So the first thing we want to do is find the 0 of x plus 4. So in that case, that is negative 4. So we're going to plug in negative 4 into the function. So we've got negative 4 to the 4th plus 3 times negative 4 cubed minus 6 times negative 4 squared minus 6 times negative 4 plus 8. And this is a good time to use our calculator, so we're going to pull that up and we'll plug this in. So we've got negative 4 to the 4th power plus 3 times negative 4 to the 3rd power minus 6 times negative 4 squared minus 6 times negative 4 plus 8. And when I hit enter, I get a value of 0. So p to the negative 4 is equal to 0. What does that mean? It's got a special meaning because there is no remainder, which means that x plus 4 is a factor of p of x. Okay, and we'll dive into that further as we go through the unit. So that's today's lesson. Peace.
That's all, folks.